Dear students, let's continue our discussion on trigonometric functions. In the last class, I had defined what are trigonometric functions, like sin theta is equal to opposite by hypotenuse, cos theta equal to adjacent by hypotenuse, etc. Let me define the trigonometric functions in another way by considering a circle. Let me consider a circle with the center at origin and radius r. Okay. I will take this circle. The center of this circle is at origin and radius is r. Okay. I will choose a point P of x comma y on this circle. Choose a point P x y on this circle. Let this point be P x comma y. Okay. Join this OP. That OP is the radius. This is our x axis. This is y axis. This is positive x axis, negative x axis, positive y axis and negative y axis. That much you know. Okay. So, I have chosen a point P of x comma y on the circumference of this circle. Okay. Now, I will draw a perpendicular from that point P to x axis. Draw a perpendicular from P to x axis. I will take this point as M. Let M be that point. Okay, I have drawn PM perpendicular to x axis. Let this angle MOP, I will take this angle as theta. Always we will consider the positive x axis as the initial line. So, from here we measure all the angles. Okay. That angle I have considered it as theta. Okay. So, angle MOP equal to theta. Now, this point is x comma y. That means this distance OM will be equal to x and this distance will be equal to y. PM is equal to y. If that point is x comma y, then OM is equal to x and PM is equal to y. Okay. OP is equal to r, the radius. Okay. Now, there is one right angle triangle is formed, and that OMP, triangle OMP is a right angle triangle. It is Lambakona Tribuja, OMP. Okay. So, from that right angle triangle, I can write sin theta is equal to, sin theta is nothing but opposite by hypotenuse, which you know, PM by OP, PM by OP, that is equal to y by r. And cos theta is equal to OM by OP, which is equal to x by r. Tan theta is equal to PM by OM, which is equal to y by x. Secant theta, as we know, secant theta is defined as hypotenuse divided by adjacent, which means OP divided by OM, that is equal to r by x. Cos theta is x by r, therefore secant theta, which is the reciprocal of cos theta, will be equal to r by x. Then cosecant theta, that is equal to, cosecant theta is defined as hypotenuse divided by opposite side. So, OP divided by PM, that is equal to r by y. And finally, cot theta is defined as adjacent by opposite, which means cot theta is equal to OM divided by PM, that is equal to x by y. As you can observe, tan theta equal to y by x, therefore cot theta being the reciprocal of tan theta will be equal to x by y. Okay. So, here this is another way of not another way, here also we are considering right angle triangle only, but by drawing a circle with the center at origin and radius r, we can define the trigonometric functions in this way. See, here I have chosen that point P of x comma y in the first quadrant. Okay. As we know, in the first quadrant x comma y, if I take a point x comma y in the first quadrant, then both x and y are positive. You know, you have learnt that already in your previous classes, earlier classes, you have learnt that when you were in high school, that when a point is in first quadrant, then both x and y are positive. If it is in second quadrant, x is negative, y is positive. If the point is in third quadrant, then x is negative, both are negative. In fourth quadrant x is positive and y is negative. Why it is so, that also I will explain now. See here, this board, we can imagine this board as a plane. That plane is divided into 4 equal parts by these 2 perpendicular lines. These 2 perpendicular lines, they divide this plane into 4 equal parts. Okay? The perpendicular lines are called the x-axis and y-axis or coordinate axis. X-aksha, y-aksha anta kariteve. Okay? In this is called OX, that is called positive x-axis, and this direction, let me call it as x dash, OX dash, this is called negative x-axis, and this OY is called positive x-axis, positive y-axis, sorry, and this OY dash, which is called negative y-axis. Okay? Now, here, first quadrant, you take any point in the first quadrant, the boundaries of first quadrant, boundary in the sense, this side it is unbounded, okay. So, that side it is unbounded, this side it is bounded by positive x-axis and positive y-axis. ಇದರದ ಬೌಂಡ್ರಿಗಳು ಒಂದು ಪಾಸಿಟಿವ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಇನ್ನೊಂದು ಪಾಸಿಟಿವ್ ವೈ ಆಕ್ಸಿಸ್. Therefore, in the first quadrant we say that x and y both are positive, x coordinate as well as y coordinate both are positive. Now coming to the second quadrant, this is called first quadrant. This is second quadrant, third quadrant and fourth quadrant. Quadrant andre nalkane ondu bhaga. This is a plane, that plane is divided into 4 parts, so each part is called a quadrant. Okay. So first quadrant, positive x axis, it is bounded by positive x axis and positive y axis. So here both are positive, x is positive, y is also positive. And look at second quadrant. In the second quadrant, x is negative, it is bounded by negative x axis and positive y axis. So here x is negative and y is positive, x is negative, y is positive. Then third quadrant, it is bounded by negative x axis and negative y axis. Therefore, there both are negative, x coordinate is negative, y coordinate is also negative. Then in the fourth quadrant, it is bounded by positive x axis and negative y axis, positive x axis and negative y axis. So, there we say x coordinate is positive, y coordinate is negative. X coordinate is positive, y coordinate is negative in the fourth quadrant. We are very well aware of all those things. Now, we know total angle in a circle is 360 degree. We always consider positive x axis as the initial line. We measure all the angles by treating this as the initial line, and we measure in this way by considering this as the initial line. Okay? So, if we move in this way, here angle made by, say, let me call this marker, along with take this marker, this is the angle made by this marker along with x axis. What is the angle? 0 degree, right? Both are along the same direction. So, here we consider 0 degree, and this angle XOY, this angle is 90 degree, right? So, this is 90 degree here, and this will be 180 degree, right? From 0 to this angle, total angle here till 180, and here this will be 270 degree. From here to here I am saying, that is 270 degree. Then what happens to this? If I come back here, that will be 360 degree again. Okay, right? Then, so if an angle lies in between 0 and 90 degree, then we say that that point, the position of that point is in first quadrant. Okay, so the position of the point means somewhere here, if I take a point and I draw this line and I measure this angle, that angle will always be in between 0 and 90 degree. That's what I mean. Okay, then if I say, suppose if the point is in between if the point is in second quadrant, then the angle made by the line joining the origin to that point and x axis, this angle will be in between 90 and 180 degree. If the point is in second quadrant, then that angle made by this line with the OX, that is the positive x axis, will always be in between 90 and 180 degree. Similarly, if it is here, if the point is here, then the angle made by the line joining that point with the origin with the x-axis is between 180 and 270, and if a point is in fourth quadrant, then the angle is between 270 degree and 360 degree. That is in terms of degrees. In terms of radians, this is 0 radian only. Here pi by 2 radian, 90 degree equal to pi by 2 radian, 180 degree is pi radian, and 270 degree is 3 pi by 2 radian. Again 360 degree, that is nothing but 2 pi radian. Okay. So now given one angle, you can easily identify it lies in which quadrant. Okay. So if I ask you 135 degree, 135 degree is greater than 90 but less than 180 degree, therefore it lies in the second quadrant. Then if I ask you what about 260 degree, 180 degree is here, 270 degree is here, so 260 will be somewhere here, which is greater than 180, less than 270, therefore it lies in the third quadrant. In that way we can identify. Okay. Now let us look at these trigonometric functions and identify where they are positive, where they are negative, etc. Okay, in which quadrant it is positive, in which quadrant which of those trigonometric functions are positive and which of them are negative, that we shall find out now. Okay. So first let me start with the first quadrant. If I have chosen that point p x comma y in the first quadrant, okay, let us say here first quadrant, if I choose, this is the angle theta, this is the point x comma y, this is the x, y, r. R is always positive. The r is nothing but the radius of the circle. Radius can never be negative. It is always positive wherever the point may be. Okay, that point is in first quadrant, second quadrant, third quadrant, or fourth quadrant. So if I choose anywhere on the circle, that r, that is always positive. X and y may be positive, may be negative, depending on which quadrant it lies. Okay. So now I have considered the first case where the point lies in the first quadrant. So if the point lies in the first quadrant, their x as well as y, x coordinate as well as y coordinate, both are positive. R is anyway positive. Therefore, look at this. Sin theta is y by r, positive by positive, x by r, cos theta is x by r, positive by positive, this is positive, this is positive. All the 6 trigonometric functions are positive in the first quadrant. So when theta lies in the first quadrant, or here when p of x comma y lies in the first quadrant, then all the 6 trigonometric functions are positive. Now let us consider the second case. Let me choose that point in the second quadrant. So if I choose it in the second quadrant, okay, so I have taken a point here, p x comma y. This is the point p x comma y. Here I am drawing a perpendicular. This is x, this is y, this angle is theta, this is r. Okay. So I have chosen p of x comma y in the second quadrant. This is our initial line. The positive x axis is the initial line. Okay. Now if it is in first quadrant, if it is in second quadrant, then look at sin theta. What is sin theta? Sin theta is equal to y by r, you know. Sin theta is equal to y by r. Here in the second quadrant it is, so x is negative, y is positive. So sin theta will be y by r, means positive by positive, that will be equal to positive. But what about cos theta? Cos theta is nothing but x by r, adjacent by hypotenuse, x by r, that will be equal to negative by positive, which is equal to negative. Cos theta is x by r, which is negative by positive, so negative. That means when theta is in the second quadrant, cos theta will be negative. Sin theta is positive, cos theta is negative. Let us see what happens to tan theta. Tan theta, it is defined as opposite by adjacent, y by x. Y is positive, but x is negative. Positive by negative will be equal to negative. Okay. And their reciprocals, since sin theta is positive, its reciprocal cosecant theta is also positive. Cos theta is negative, therefore its reciprocal secant theta is also negative. Then tan theta is negative, therefore its reciprocal, what is the reciprocal of tan theta? Cot theta, that's also negative. So from this we observe that if theta lies in the second quadrant, then sin theta and cosecant theta are positive. All the other trigonometric functions are negative. Now let us consider the third case, that is if the point lies in the third quadrant. If it lies in third quadrant, then what happens? Let us see. Okay, this is the second quadrant. Now third quadrant, let me write here. I am choosing a point here P x comma y. From origin I will draw a line, draw a perpendicular here. This is the angle theta. Here theta is greater than 180 degree, less than 270 degree. This will be x, this is y, this is r. R is always positive. Now x comma y lies in the third quadrant. Therefore x as well as y both are negative. So here what happens? Sin theta is equal to y by r. Y is negative, r is positive. Negative by positive is negative. Then cos theta is equal to x by r. Negative by positive, that will be equal to negative. And tan theta is equal to y by x. Negative by negative, that will be equal to positive. Okay. So here x and y are negative and r is positive. Therefore y by r, x by r are negative, whereas y by x is positive. Therefore in the third quadrant tan theta is positive, and when tan theta is positive, obviously cot theta is also positive. So here from this we can conclude that in the third quadrant tan theta and cot theta are positive, rest of the trigonometric functions are negative. That is in the fourth quadrant, sorry, in the third quadrant. Now let us go to the fourth quadrant. Fourth quadrant. I will take one point here p x comma y. If p x y lies in the fourth quadrant, what happens? Let us observe. Okay, this is x, y, r. This is the angle theta. Okay, that angle is greater than 270 degree but less than 360 degree. When it is greater than 270 degree but less than 360 degree, that means it lies in the fourth quadrant. In the fourth quadrant, x is positive, y is negative. Here what happens to these trigonometric functions? Let us observe. Sin theta is equal to y by r. Sin theta, y is negative, r is positive. So negative by positive is equal to negative. Then cos theta equal to x by r. X is positive here in the fourth quadrant, r is always positive. Positive by positive is equal to positive. Then tan theta will be equal to y by x. Y is negative, x is positive. So tan theta is also negative. Hence in the fourth quadrant, cos theta and its reciprocal secant theta, they are positive, and the remaining four trigonometric functions are negative. Okay, is it clear? So from this we can say that in the first quadrant all the six trigonometric functions are positive. In the second quadrant, sin theta and cosecant theta are positive, remaining are negative. In the third quadrant, tan theta and cot theta are positive, remaining are negative. In the fourth quadrant, cos theta and secant theta are positive, and rest of the trigonometric functions are negative. This you have to remember. You can remember in this way. ASTC. Maybe you are aware of this. Here A stands for all, S for sin, T for tan, and C for cos. See, even though there are 6 trigonometric functions, but we will mainly concentrate on the first three, that is sine, cos and tan, because the remaining things secant, cosecant and cot can be obtained by taking the reciprocals of those three, right. So, here in the first quadrant all are positive, in the second sine is positive, sine is positive means obviously cosecant also positive, in the third quadrant t is positive, that means tan is positive, and in fourth quadrant cos is positive. Okay. So, ASTC, you can remember this as what you know, right, all silver teacups. You can remember it in this way, or you can write all students take coffee. In this way. Okay. I mean, it is just for remembering only. Trigonometry has got nothing to do with the teacups or students taking coffee. Okay. So, the thing is, you should know this, ASTC, all are positive, sine is positive, tan is positive, cos is positive. Okay. Here all are positive, here sine and cosecant are positive, remaining are negative, here tan and cot are positive, remaining are negative, here cos and secant are positive and the remaining trigonometric functions are negative. Okay. Then, now, if I give you one angle and ask you to check whether it is positive or negative, what we do is, first we will identify in which quadrant that angle lies. Then, in that quadrant, what happens to that particular trigonometric function, that we can decide. So, for example, if I ask you what about sine 150 degree, say I am not asking you what is the value of sine 150 degree, which we shall discuss in the coming classes. My question is whether sine 150 degree is positive or negative. So, for that what we should do is, first you identify where does this lie. 150 degree, where does it lie? It lies in the second quadrant, yes. In the second quadrant, what about sine? In the second quadrant, sine, is it positive or negative? Positive, yes. So, sine 150 degree is positive. Okay. Next, if I ask you what about cos 212 degree. 212 degree. 212 degree, you know, it is greater than 180 degree, but less than 270 degree. 212 right lies in between 180 and 270. Greater than 180 degree, less than 270 degree means it is in the third quadrant. In the third quadrant, cos, what happens to cos? In the third quadrant only tan is positive, so cos is negative there. So, cos 212 degree is negative. Then what to do? Then I will take one more problem, say secant 135 degree. Okay. Secant 135 degree I will take. 135 degree, it is in which quadrant? 135 degree is in second quadrant. Between 90 and 180, if it is between 90 degree and 180 degree, then we say that it is negative. So, secant, if it is in between 90 degree and 180 degree, we say that it is in second quadrant. In the second quadrant, secant theta, what happens? So, if you do not know secant theta, you think of its reciprocal. What is its reciprocal? Cos. Cos theta in the second quadrant is negative, because in the second quadrant sine and cosecant are positive, remaining are negative, therefore, this is negative. Okay. Next, tan 315 degree. 315 lies in which quadrant? 315 degree lies in fourth quadrant. 315 degree is greater than 270 degree, but less than 360 degree. If the angle is in between 270 and 360 degree, then it lies in the fourth quadrant. In the fourth quadrant, only cos and secant are positive, remaining are negative. So, tan 315 degree is negative. Okay. Is that clear? Okay. Students, with this I will end today's class. In the next class, we will see some more problems on this, where we will have to identify whether they are given trigonometric function is positive or negative, and some more problems of on that. Okay. Thank you.